All right, we are working on systems of equations. We got our test tomorrow. Here is a review. Let's get started. On 1 through 8, I believe, we are just solving the systems of equations any way you know how. We can use elimination, substitution, or graphing. Every problem kind of gives you a method that's easiest. Starting with number 1, they tell you what y is, so we're going to substitute that in for y. That gives us 3x plus 2y equals 96. Y is x plus 8. So, distribute 2x plus 16, carry down the 3x, equals 96. Combine like terms, we have 5x. I'm going to go ahead and minus 16 to both sides, and we get 5x equals 80. When you divide by 5, you get x equals 16. That is half of your answer. The full answer has to be x and y. So, step 2, you're going to take y equals x plus 8, but we know what x is. X is 16. So we have 16 plus 8. And we end up with y equals 24. Number 2, we have 4,781x plus 8y equals 16, negative 4,781x minus 6y equals negative 12. Big ugly numbers there, but they match up. Therefore, they are eliminatable. So we're going to add the two equations together. Positive that plus negative that goes away. Positive 8y plus negative 6y is 2y equals 16 plus negative 12 is 4. So y equals 2. Half of our answer. Take whichever one of these equations looks the prettiest. I'm going to say the first one, 4,781x plus, here we have 8y, but y is 2. So 8y is 16, equals 16. To solve for x, you minus 16 from both sides. 4,781 times x equals 0. The only thing x could be is 0. So look at that big ugly equation worked out to be nice and neat. You got 0, 2. Number 3, we got to decide here what method we want to use. We could use graphing. We can use substitution. I'm going to go with substitution. We got easy, what y equals there given to us. That's an easy substitution problem. 2y equals 4x plus 6. Y is 2x plus 3. So now we can solve this. 4x plus 6 equals 4x plus 6. If you notice this, we have the exact same equation twice. Actually, looking back up here, this one is just double the first one. Think about the graphs. It's going to be the same line twice. If you think about the pictures from Sam's that I gave you, it's going to be me buying the same thing, but double. You don't have enough information here, which means infinitely many solutions. The other way you can see that, if I subtract 4x from both sides, I'm going to have 6 equals 6, which is always true. So there's number 3. That is our answer. Number 4, I could use substitution. I would just have to plug this thing in for y, but I don't like those fractions. One thing that is easy to do is graphing. So I'm going to graph this. I'm going to throw in a little graph here. Let's stick that here. Y equals 1/3 x minus 2 is easy to do. Start at -2. Our slope is 1/3, so we rise 1 and run 3. And we end up with that line there. Down 1 over 3, down 1 over 3. My line got a little bit off, but close enough. The blue one, 2x plus y, I need that to be in y equals form. I have minus 2x to both sides. I get y equals -2x plus 5. 1, 2, 3, 4, 5 is my y-intercept. -2 over 1 is my slope. So down 2 over 1. Down 2 over 1, down 2 over 1, and I see my intersection point. Here's where they intersect, which is 1, 2, 3, comma, -1. So this ordered pair, that is a good enough answer to write it that way. Or you could say x equals 3, y equals -1. Either one of those are just as good. Number 5. Looks like it'd be good to graph, but those numbers are too big to fit on a graph. On the test, you cannot graph on your calculator. That's not one of the usable ways. I'm going to set up substitution. This is y, so I'm going to put it in place of y and say 15x plus 4 equals 5x plus 34. Minus 5x to both sides. And we're going to get that to cancel out, and not 20, 10x. At the same time, I'm going to go ahead and minus 4 to both sides to get 30. So x equals 3. Once I know that x is 3, I'm going to take this bottom equation and say that y equals 5 times x, which is 3, plus 34. That is 15 plus 34, which equals 49. So y equals 49. Number 6. I'm trying to decide which way to do this. Really, all 3 ways would work here. I'm going to go with elimination. I want to try to make the y's match up here. So I need 2y on the bottom. I'm going to multiply by 2, actually -2, so that I have positive 2 up top and -2 down bottom. That gives me -2x plus -2y equals -10. Here, the top one stays 3x plus 2y equals 10. All I need to do is add the 2 equations together. I know to add because that's what will make this cancel out. So, add the 2 equations. 3x plus -2x is x. That goes away. 10 plus -10 is 0. Half my answer. Go back to the prettiest equation, which looks like this right here. We have x, which is 0, plus y equals 5. That makes it pretty obvious that y has to be 5. 7 and 8, just to save a little bit of time, I've already gone through all 3 methods. I'm going to pause it and give you the answer. All right, here on number 7, graphing seems to be the easiest. When I graph the 2 lines, I get the intersection right here at -3, 2. Number 8, a little bit tricky here. I went with something that you might not think of so quickly, but the problem, I went with substitution. The problem tells me what 1.7y is. I know normally I've told you, and our notes say that we need to find what y is. But if you notice in the first equation, it uses 1.7y. The second equation gives us what 1.7y is. So as long as they're the same, I can substitute this 3x minus 15 in for 1.7y. So it's kind of a little trick to save you a lot of ugly numbers there. That gives us this equation over here, which is 5x plus, is that a plus? I colored over it. 5x plus this right here, which is 1.7y, 3x minus 15. So ends up giving us x is 5 and y is 0. You could go through and do it the long way, which is the normal substitution way, and you're going to get the same answer. So page 1. 9 and 10, same thing. I'm just going to give you the answer. That's just more problems like we've been doing. All right, number 9, I went with the elimination method. I noticed that if I double the top equation, it's going to cancel out the x's. However, once I did that, I noticed I got the exact same equation twice. So same equation twice is always an infinitely many solutions. If you were to subtract here, you're going to end up with 0 equals 0. So infinitely many solutions. Number 10 went with the substitution method. I solved for this x, and I got x equals y plus 9. Substituted it in right here, solved all the way down, got an ugly answer, negative 2.4. Took that y value, plugged it into this equation to get x equals negative 2.4 plus 9, which is 6.6. So there's your answer. The graphs, I did them as we went, so I didn't use these. Moving on to number 9. This is a new topic. Combining two old topics. It's not something I directly taught you, but it's something that you can easily figure out if you just remember what we've learned in the past. Systems of equations is what we just did. That's two equations joined together. System of inequalities is when you have two inequalities joined together. Remember, an inequality is where you have the less than or greater than, and you have to shade. So we're going to graph 3x minus 2, which is starting at negative 2. Our slope is 3 over 1, so up 3 over 1. And it's going to look something like this. The less than or equal to tells us a solid line, and we shade below. Yeah, I think way back for that. So there is its graph. The second equation, y is greater than, let's use blue for that. 1/4 x plus 2, we start at 2. Our slope is 1/4, so we rise 1, run 4. Greater than tells us a dotted line, and we shade above. So let's get the blue highlighter, shade above. And our solution, just like with systems of equations, our solution is the x and y that works for both equations. So same thing with inequalities, our solutions are the x's and y's that work for both inequalities. So as far as the shading is concerned, it's the points that are in both shaded areas. Well, the only area of that graph that's shaded by both colors is this little piece up here in the top corner. That's shaded by pink and blue, or purple and blue. So we're looking for ordered pairs that are in that zone. So looking at our answer choices here, there are more than one answer, the problem says. I just need to plot them. So I'll plot them with yellow. That'll stand out. 3, 1 is over 3 up 1. That's a solution to the pink equation, not the blue equation. So no. -2, -3 is neither. 4, 6 is 4 right there. That is a good one. 4, 3 is on the line. That's always questionable. That's going to mean it's going to be equal to 1/4 x plus 2. However, our inequality sign says it has to be greater than, not equal to. Here we have a dotted line, not a solid. So no. -1, 4. -1, 4 is not an inequality, or not on the not in double shaded area. Sorry. And then f 1, 1 is on the solid line but it's not in the blue area, so no, and uh-oh. It says there's more than one, but there's not. So, trick question, making sure you're paying attention. There is only one, and that's 4,6. Number 10, a Sonic cheeseburger is $3.79. Classic chicken sandwich is $4.09. I bought twice as many chicken sandwiches as cheeseburgers, and the total cost was $95.76. How many of each sandwich did I buy? This was written a little differently than you might have been used to, because that's not the same type of word problems you saw before. However, there were some flooring problems out on our walk around where you're putting green carpet and blue carpet and all that. So our actual unknown values here are the number of chicken sandwiches. We'll call that C. Hamburgers we'll call H, or cheeseburger. How about this? Chicken sandwich and cheeseburger. CB and CS. So a Sonic cheeseburger is $3.79. And a classic chicken sandwich is $4.09. I bought twice as many chicken sandwiches as cheeseburgers. So the total cost, $95.76, is going to equal the number of cheeseburgers times, let me write that backwards, 3.79 per cheeseburger plus 4.09 per chicken sandwich. That's one equation. I bought twice as many chicken sandwiches as cheeseburgers. So the number of chicken sandwiches is twice as many as cheeseburgers. It says how many of each sandwich did I buy? I'm not going to make you solve that. I know the review says you do. Equation here is good enough. Those numbers are pretty ugly. I'm going to assume with all the practice we've done, you could eventually get that taken care of. Number 11, Bill hates Sonic, but his wife always wants to eat there. They always argue. Bill thinks it's time for a divorce. This was student written, by the way. Bill spends $9.48 total on a number 15 and a number 18. The number 18 costs $2.10 less than the number 15. What is the price of each combo? So my variables, I'm going to make them the actual 15 and 18 just circled. So I know that's not really letters, but it'll make sense. So a number 15 plus a number 18 is 948. That's the first equation. This is not the number 15. It's the combo value 15. The number 18 costs how much? $2.10 less than the number 15. So the number 15 minus $2.10. Same thing here. The problem wants you to solve it. I'm going to let you just write that and be done with it. Number 12, State Fair sells two types of hot dogs. Regular, which is R, jumbo, which is J. Regular hot dogs cost $5 each. Jumbo costs $7 each. 7,250 hot dogs are sold. 46,250 is collected. Figure out how many regular hot dogs were sold that day. So, if there were 17,250 hot dogs sold, well, that is the regular plus the jumbo combined. The money equation now, we have 46,250. They made that money by earning $5 for each regular plus $7 for each jumbo. I want you to find how many regular hot dogs were sold. This would be a elimination problem I would go with. I'm not going to make you solve that. Writing it's good enough. 13. Two functions are